The last video looked at rational expressions. Rational expressions were when you had expressions that looked like fractions, really. You had something with x, maybe it was a monomial, maybe it was a binomial. Sometimes we either had trinomials over another monomial or binomial or trinomial. Today we're going to talk about how to multiply or divide rational expressions. And we're going to do 4 simple steps. The first step is always to factor. We're going to factor any polynomial that we can. We're going to determine any restrictions. I want to do this early so that if anything is canceled, we remember. I'll show you what I mean. Number 3, we're going to, when dividing rational expressions, multiply the reciprocal of the rational expression. Ugh, okay, that sounds awful. But does everybody remember way back when we were doing fractions? 1/2 divided by 3/4. How did we do that? Well, if you're dividing by a fraction, what we're going to do is we're going to take our first number is fine. Our second number we're going to flip. So instead of 3/4, we do 4/3. And now it becomes a multiply. Well, how do you multiply fractions? You multiply the 2 numerators, and you multiply the 2 denominators. 2 times 36. For rational expressions, we're going to do the same thing. If you see a division, you're going to take your second rational expression, you're going to flip it and multiply. That's what I mean by multiply by the reciprocal. Multiply by the reciprocal, flips, if you will. All right, and then at the end, to simplify, we're going to divide by any common factor. The rules sound kind of confusing, but they're actually really easy to follow. So let's try example 1. Example, simplify each expression and state any restrictions on the variables. So first, can we factor anything here, 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 here? No, they're all monomials, can't factor. My restrictions. What would make my denominator equal 0? Well, 3 times 0, that would be no good. Or 2 times 0, that would be no good. X cannot equal 0. Restrictions, again, are values that make the denominator equal 0. So we're done 1, we're done 2. Now we're going to treat it just like we would any other fraction. 4x squared times 12x to the cube. Well, we multiply the 2 coefficients. 12 times 4. 48. X squared times x cubed, well, that's 2 x's, if you will, and 3 x's. So how many altogether? 5. For our denominator, 3 times 2 is 6, and x times x is x squared. All right, let's see if we can do any simplification. 48/6, 48 divides by 6, that's 8. And x to the 5, x to the 2, you can think about that as if it's 1, 2, 3, 4, 5 x's. That's what x to the 5 means. And that's 2 x's. All right, well, that would cancel with that. And this would cancel with this, and I'd be left with just 1, 2, 3 little x's. So simplify each expression as long as x cannot equal 0. State my restriction. All right, let's try the next one. For our next example, we're going to simplify this expression and state any restrictions on the variables. I like to start my restrictions right at the beginning, right after I check to make sure that there's nothing I can factor. My restrictions. Our a cannot be 0, because that would make that 0, and b cannot be 0, because that would make that 0. To simplify this, I'm going to treat it like a fraction. When I divide fractions, the first part stays the same. The second part is going to become the reciprocal. It's going to flip. So instead of 15a squared on the top, it's going to be 15a squared on the bottom. It's going to be 12b squared on the top. Instead of being divide, now that I flipped it, it's multiply. Next step for this would be to check. Now that I've got a new term, if you will, on the bottom, I need to make sure that any restrictions that need to be added are added. This is telling me that A cannot be 0 either. So if A cannot be 0, oh, it's already listed there, so I don't need to add anything. Other times you may need to add a third restriction in this case. Now I'm going to multiply 10 times 12, 120. A is just A, B squared times B squared, B to the 4. 4 times 15, 60. A times A squared is A to the 3. 120 divided by 60 is 2. A over A squared, oops, A to the 3, A squared. How did I do that? Well, we had A on the top, and we had 3 A's on the bottom. One of each cancels. I'm left with 1 over A squared. And my B to the 4 stays. So my final answer is 2 B to the 4 over A squared, as long as A doesn't equal 0 and B doesn't equal 0. So with our last two examples, the factoring step didn't need to happen. Here it does. If I have A squared plus 2A, I can definitely factor something out. I can factor out an A. If I factor out A, I get A from this term plus 2. Can I factor out anything from the denominator? Nope. 3A. 20A, nothing can get factored out, but from the denominator I can factor out a 5 and I can factor out an A. So I'm left with A there plus 2. Now that I have it all factored, I can state the restrictions. A in this case, not X, cannot equal 0 or 0 or negative 2. What value makes this bracket 0? A negative 2 plus positive 2 makes 0. Put the numerators multiplied by numerator. A times A plus 2 times 20 times A squared, all over 3A times 5A, 15A squared, A plus 2. What cancels here? Well, A squared and A squared cancel, A plus 2 and A plus 2 cancel, and let's make this lowest terms, 20 and 15. What could I divide both 20 and 15 by? 5. 20 divided by 5 equals 4, and 15 divided by 5 equals 3. So we're going to have as our final answer A and 4 gets left is 4 over 3. Or we can write that as 4 over 3A, as long as A does not equal 0 or negative 2. Let's go for it. First step, let's factor this out. 2x squared minus 8x, I can factor out a 2 and an x. I'm left with x minus 4. My denominator, the polynomial. So that means I'm looking for two numbers that multiply to negative 10 and add to negative 3. So that's got to be an x minus 5 and an x plus 2. Let's check that. Every time, for these questions, we're going to do a lot of factoring. Each time you do it, it's beneficial to check right away. Otherwise, if you've got a sign wrong here, if you've got the wrong number here, it's going to take forever to find it once you've done 6 or 8 other lines. This would give me x squared. Negative 5 times x, negative 5x, plus 2x. Negative 5 plus 2. Yeah, that gives me the negative 3 I expect. and negative 5 times positive 2 gives me negative 10. Good, I've got it factored correctly. I'm going to keep this as a division for now. 4x squared divided by, now I have to factor this. I need two numbers that multiply to 20 and add to negative 9. X minus 5, x minus 4. X squared minus 4x minus 5x, yeah, that's negative 9. And 4 times 5 is 20. Good. As long as I'm here, let's start a tally for restrictions. I see that x cannot be, here it's telling me 5, here it's telling me negative 2, here it's telling me 5 again, and here it's telling me positive 4. I'm dividing a fraction. So let me flip and multiply. 2x, x minus 4, over x minus 5, and x plus 2. My first fraction stays the same. I'm going to now multiply by x minus 5, x minus 4, over 4x squared. Now some of you are getting the hang of this. Some of you are going to say, well, like, can we cancel right away? Yes, you can absolutely cancel this, and you're going to cancel the x and x's as well. If you're not ready for that, let's put them together. Multiply the numerators all together. We have 2x, x minus 4. Now that's multiplied by x minus 5 and x minus 4. All over x minus 5, x plus 2, 4x squared. We'll just put in a bracket. Why not? Everything in brackets. All multiplied together. Any terms that we can find both in the top and the bottom, it's like multiplying by one number and dividing by the exact same number. What can I find? This and this. Anything else? Nope. This is not the same as this. This is not the same as that. Nothing else. I've just realized something. Once I make this flip, and I have now x on the bottom, I have a new number. That's a restriction. I have a new value of x. That's not going to work. If I put x equal to 0, we're going to be dividing by 0. We're going to get undefined. So back up at my restrictions. Because of this x right here, x cannot equal 0 either. 4 restrictions. Now we're ready for the simplified. And we're just going to leave it as factors. I'm going to write 2x, x minus 4 and x minus 4, x minus 4 squared. I'm going to put this out front. It's always nice to have terms without plus or minus out front, then you don't need the brackets. Doesn't really matter, kind of how the textbook writes it. That's my simplified form. My restrictions are x cannot equal 5. Oops, let's put them in order. Negative 2, 0, 4, and 5. I just realized a really little mistake. If you look at 2 over 4, think of it as a fraction. 2 over 4, well, that's the same as 1 over 2. That's really what lowest terms is. That's what this should look like. This 2 and that 4 is going to get replaced. X minus 4 squared over 2 x squared, x plus 2. The restrictions remain x cannot equal negative 2, 0, 4, 5. And that's the simplified with restrictions form.